Hello, welcome back to Math with Patrick. It's May 15th, and we're solving problem number 135 from the Daily Epsilon calendar. And today, x should be 15. That matches today's date. And I guess we should solve for what this y value is, and then plug it in here, and then get x. Before we do, I want to talk quickly about this little thing right here. I know in this setup, y and x are reciprocals, or like flips of each other. And I just want to show like one example to kind of prove my claim. If I have like 1 divided by, let's say like 3 halves, I know that this is the same thing as 2/3. One way to think about it is just doing like fraction division. And so this would be the same thing as like 1 divided by 3 halves. And then you can keep, change, and then flip, and you're not going to change the value of what you have on this side. Usually, I like to think of fraction division as fraction multiplication. It just kind of makes more sense in my head. And then 1 times anything is just itself. So with these steps, I have shown that 1 divided by a fraction is just its reciprocal. And you could also think about this in another way with actually just thinking about division. Here I'm trying to ask how many 3 halves fit in the number 1. And it doesn't, right? Because 3 halves is bigger than 1. Though if I have this little picture model, let's say that this is the distance or the length of just 1. And I ask, how many times does 3 halves fit into here? So this will be, 1 half, 2 halves, and then 3 halves. Well, clearly all of it doesn't fit in there, but 2/3 of it actually does fit exactly into 1. So thinking about division as like fitting one number into another, you can also see that 2/3 of it does fit in the number 1. And so that's just like one more layer of confidence that the answer is 2/3. And hopefully these two examples can kind of prove to you that x and y are reciprocals, or just flips of each other. So x and y are reciprocals. And so when I finally figure out what my y value is at the end of the video, I'm just going to flip it. Like I'm hoping it's a fraction, right? And then I'll flip it and get 15. So I'm really hoping that y is going to be equal to 1/15th, because when I flip that, I'll get 15 over 1, which is the same thing as just 15. So let's run through all of this arithmetic, and let's see if we get 1/15th at the end. So y is equal to the square root of, and then 28/63 plus 36 hundredths minus 96 120ths. Okay, really large numbers. I'd like to be able to like square root something squared, right? Because these would cancel out. And then y is supposed to be 1/15th. So I really hope that I can get this kind of setup out of these fractions. And looks like I should probably find some kind of common denominator, because I have 3 fractions currently. I want to shove them all into 1. So finding a common denominator is a good idea here. I think before I do that, though, I should simplify them, right? Because like here we have 2 even numbers, like the numerator's even, the denominator's even. Same thing going on over here. Maybe I could simplify the first fraction as well. And probably simplifying them first would be nice before I try combining them. So let's try to do that. Well, with the middle one, both numbers are even, so I could divide both by 2. So I'll get 18 over 50. I could do the same thing again, right? That's 9 over 25. And then now I don't have any shared factors on the top and bottom. There are some 3's hiding up in here and some 5's down in there, but nothing in common. So I know I can reduce this fraction to 9/25ths, and that's as far as it goes. For the one on the right, I'll play the same game. I do know that 96 divided by 4 is 24, and dividing the bottom by 4, I get 30. So I can go, wow, this one reduces really far. There is a common factor of 6 in both of these. So I can divide 24 by 6 to get 4. and then 30 by 6 to get 5. So this fraction right here is just 4/5. But there's like a, you multiply by some factor on the top and bottom to get it to this other form. Or in other words, you divide it in the top and bottom to simplify it into a better form. 4/5 is a little bit easier for me to work with and think about. Okay, 63, that's 7 times 9. 28 is 7 times 4, so there's a 4 in the top and bottom, and I'll cancel those out in my head. I'll get a 4 on the top and then a 9 on the bottom. Okay, cool. So simplifying them was the right way to go. I like working with smaller numbers. I think you do too. Now I guess I should find a common denominator and then like shove them all together. There are some 5s here. It's 5 times 5. There are some 3s in here. And I think I just need to multiply like the different fractions the right amount to match their denominators. Maybe I'll rewrite it to give myself a little bit more room. Okay, so this was 4/9, and I'm going to multiply the top and bottom here by 25 because I need to have kind of the 2 5s that are in here also in that fraction. For the next one, I'm going to do something similar where I need some 3s in the bottom of that guy, and I don't have any. So I'll take the existing 9/25 and then put some 3s in the bottom, so times 9, and I need to keep my value the same by multiplying the same number up top. And then for this last one, I have 1 5 in here already, but I do need a second one. And then I also need to stick the 9 in here as well. So I'll be multiplying the existing 4/5 by whatever 9 times 5 is, so 45. And then this way, I should have the same denominator in all 3 fractions. So yeah, 9 times 25 is the same as 25 times 9. And then that should also be the same thing as 5 times 45. So let's figure out what the numerators are as well. Well, okay, I didn't actually figure out the denominator yet. I know 8 times 25 is going to get me to 200. So another one is going to be 225. And then here I have 100 plus 81 minus 90, 180, I think. I took 45 and then multiplied it by 2, and then by 2 again. So yeah, that's 180. Okay, oh, cool. And then 100 plus 81 is 181 minus 180 gives me 1 over 225. And then 225 happens to be a square number. That's 15 times itself. Real quick, I'll show that. 5 times 5 is 25. 5 times 1 plus the 2 is a 7. Placeholder 0. 1 times anything is just itself. And then adding this up, I do get 225. So this is the same thing as the square root of 1 over 15 squared. That's the same thing as just squaring 1/15. And then here's that setup that I really wanted. I wanted something squared and then the square root over it. And so I know that y is equal to 1/15. And like I was saying before, y and x are reciprocals, so this proves that x is 15. Cool. So that was some fun fraction math. I'm surprised that it simplified down so nicely, but I guess it had to because the answer was a whole number. So x is 15, that's my solution, and we're all done. Thanks for coming along. I'll see you tomorrow.